In this lesson, we will study translations of the graphs of the sine and cosine functions. First, let's start with a little bit of terminology. Some of this should sound really familiar to you from your earlier studies in algebra. For horizontal translations, the graph of the function y equals f of x minus d is translated horizontally compared to the graph of y equal to f of x. So basically, if you change the argument by adding or subtracting some number d, you are shifting or translating the graph horizontally. The translation is to the right, d number of units if that number d is positive, and it will be to the left if d is negative. Now, with circular functions, we don't call them horizontal translations. We call them phase shifts. So a phase shift is a horizontal translation. Now, in the function y equals f of x minus d, this expression inside the parentheses, x minus d, is called the argument. In this first example, we are being asked to graph y equals sine of x minus pi over 3. Now, x minus pi over 3, all of this inside the parentheses, is called the argument. Now, in order for the argument, x minus pi over 3, to result in all possible values throughout one period, it must take on all values between 0 and 2 pi. This argument, this expression, must take on all values between 0 and 2 pi if we're going to result in all possible values for the graph of this function. So because of that, we set up a three-part inequality and we solve for x. We basically just take the argument and create this three-part inequality between 0 and 2 pi, and we will solve for x. We'll isolate x by adding pi over 3 to 0 and to 2 pi. Now, when we add pi over 3 to 0, you just get pi over 3. And when you add pi over 3 to this expression in the middle, well, then the pi over 3's cancel. And then we have 2 pi plus pi over 3. Now, remember 2 pi is equivalent to 6 pi over 3. So when we add pi over 3 to 2 pi, we get 7 pi over 3. This is the interval over which this function completes one period. So this is the interval here. And so what we're going to do at this point is the same thing that we were doing in an earlier lesson. And that is we're going to take this interval and we are going to divide it into 4 equal parts to find those 5 important values. Do you remember? Here's the left endpoint. Here's the right endpoint. Right there is 2 out of the 5 values. And then we want our 2 quarter points and our midpoint. Remember, our midpoint will be found by finding half the sum of our endpoints, right? This is how we're finding our midpoint. So it's half of 8 pi over 3. So it is 4 pi over 3. That's important, that your midpoint is 4 pi over 3. So what we're going to do next is find our quarter points, right? Remember, there's 2 quarter points that we want to find. We want to find quarter point number 1, right, the first quarter point, and we want to find quarter point number 3, the third quarter point, that is. Don't forget that the midpoint is technically your second quarter point, right? So that's why I say quarter point, the first quarter point and the third quarter point, okay? All right, let's create some space there. All right, so remember that we find our first quarter point by taking half of the sum of our left endpoint and our midpoint. All right? So then this is half of 5 pi over 3, which is 5 pi over 6. Awesome. Let's find our third quarter point. This will be found by taking half of the sum of our midpoint and our right endpoint. So this will be half of 11 pi over 3, which is 11 pi over 6. Now that we have our 5 important points, we will now evaluate our function at these 5 points. Our left endpoint, our right endpoint, our midpoint, and our 2 quarter points here. All right, I have my table all set up here. I have my 5 input values. I'm plugging them, each one of them in for x. All right, let's do it. When I plug in pi over 3 minus pi over 3 is 0, and sine of 0 is just 0. So we're starting our curve at this x-intercept. This is an x-intercept because your function value is 0. Next is 5 pi over 6. Please allow me to show you this. So this is y is equal to sine of 5 pi over 6 minus, now watch this, pi over 3. But I'm going to convert pi over 3 to 2 pi over 6 so that I have common denominators, so I can do this arithmetic. So this turns out to be sine of 3 pi over 6, which is just pi over 2 when you simplify. So then y is 1. So we started out at an x-intercept, now we're moving up to a maximum, so we expect to come back down to an x-intercept. So let's see if I can show you that. Y is equal to sine of 4 pi over 3 minus 1 pi over 3. Well, that's just 3 pi over 3, which is pi, and sine of pi is 0. All right, folks, you know the pattern. If we started at an x-intercept, we moved up to a maximum, and now we're coming back down to an x-intercept. What comes next? -1, that's right. All right, I went ahead and plugged in my last 2 values, and I got -1, which I expected to get, and then back up to an x-intercept. All right, now it's time to draw the curve through these points. All right, I've scaled my axes. We're starting at pi over 3, 0, so it's an x-intercept. And then we move up to a maximum here at 5 pi over 6. We come back down to an x-intercept. We move down to a minimum here at 11 pi over 6 and back up to an x-intercept. So the curve looks something like this. This is exactly how the curve of our most basic sine function looks. The only difference is that it started pi over 3 units to the right because this is a phase shift. So basically the whole curve was moved horizontally or shifted over horizontally pi over 3 units to the right. The amplitude is still 1, right? Because the coefficient right here, it's invisible, but it is 1, right? So the amplitude is 1. The period is still 2 pi. The period is 2 pi. I can show you that right now, actually. Let me show you how the period is 2 pi. The period, we learned, is 2 pi over b, correct, in an earlier lesson. The b value is the coefficient of x, and the coefficient of x is invisible. It is 1. So the period is still 2 pi. The period did not change. The interval over which it completes that period has changed. The interval used to be 0 to 2 pi, and now it's pi over 3 to 7 pi over 3. All right, here's our next one. Y equals 3 times cosine of x plus pi over 4. We're going to graph this. Now, in order to figure out the interval over which it completes one period, we need to set up that 3-part inequality. This right here represents a phase shift. Pi over 4 units to the left. Pi over 4 units to the left. This represents a vertical stretch by a factor of 3, which changes your amplitude. Your amplitude is 3 units. We did not have to do this 3-part inequality in the previous lesson because there were no phase shifts. But now that we have a phase shift, we have to set up this 3-part inequality. All right, let's get things started by subtracting pi over 4 from 0, subtracting pi over 4 from x plus pi over 4, which just isolates x, and subtract pi over 4 from 2 pi. Remember, though, that 2 pi is equivalent to 8 pi over 4. So when you subtract pi over 4 from 2 pi, we get negative pi over 4 is less than or equal to x, which is less than or equal to 7 pi over 4. This reveals the interval over which this function completes one period. What we're going to do is take this interval now and divide it into 4 parts. We're going to go find those 5 input values. All right? Please notice that your left endpoint is negative pi over 4. Your right endpoint is 7 pi over 4. What we're going to do first is find our midpoint. All right, we find our midpoint by taking half of the sum of your endpoints. So I'm adding my endpoints together, and this gives me half of 6 pi over 4, 6 pi over 4, like this, which is 3 pi over 4. So 3 pi over 4 is our midpoint. Let's find our first quarter point. We're going to take half of the sum of the left endpoint and our new found midpoint. This will be half of 2 pi over 4, which is just pi over 4, 1 pi over 4. Our third quarter point is found by taking half of the midpoint, the sum of the midpoint, and the right endpoint. So this will be half of 10 pi over 4, which is just 5 pi over 4. So now we have all of the input values at which we will evaluate our function. All right, we have our table here set up. When I plug in negative pi over 4, the argument becomes 0, and cosine of 0 is 1, and 3 times 1 is 3. All right, it seems like we're starting here at a maximum. I expect the next thing to be an x-intercept. When I plug in pi over 4 plus pi over 4 is pi over 2, and or 2 pi over 4, which becomes pi over 2 when you simplify. Cosine of pi over 2 is 0. 3 times 0 is 0. All right. I went ahead and plugged in the rest of them and did the arithmetic here and found these function values. So what we can do now is graph our function. All right, our graph starts here at a maximum, moves down here to an x-intercept, down to a minimum, back up at an x-intercept, and then finally back up at a maximum. So it looks something like this. Remember to try to make your graph look like a smooth curve here, so it looks like this. Notice that the amplitude is 3 units. That's the height of the graph above the line that's going right through the middle of your graph, which is the x-axis. So the height above the x-axis is 3 units. The height below the x-axis is 3 units. Please notice that the period did not change. How do I know that? Well, for a number of reasons. The period is 2 pi over b, and your b value is the coefficient of x, which is just 1. So 2 pi over 1, which is just 2 pi. So the period did not change. The interval over which it completes that period has changed. All right, the next one looks interesting. It's y equals 3 halves times cosine of 2x minus pi. Now, I notice a few things. First, I notice that there's a phase shift for sure, right? So the interval over which it completes a period has changed. But not only that, the period itself has changed because the coefficient of x is not 1. I also notice that this has been vertically stretched by 3 halves. All right, so let's do this first. Let us find the interval over which it completes a period. So I take my entire argument and I will isolate x. I will solve this for x. So I already solved it here for x. I hope you found the same thing for when you isolated x. What I want to do here before we move too much further into this problem is state what the period is. Now remember, the period is 2 pi over b, but notice that your b value, remember it's the coefficient of x, is 2, so the period is pi. The period is pi. The interval over which it completes that period is from pi over 2 to 3 pi over 2. What we're going to do next is we're going to take this interval and we will find the midpoint of this interval and we will find the quarter points as well. Okay, I'm hoping that at this point you're feeling really comfortable finding your quarter points and midpoints. And I found here the midpoint to be pi, the first quarter point to be 3 pi over 4, and the third quarter point to be 5 pi over 4. All right, I have our table all set up here, ready to go. Let's go ahead and start plugging things in. All right, so plug in each one of these 5 input values, and I'm going to ask you to pause the video here, plug in each one at a time, right, in for x, do the arithmetic, evaluate this cosine function, to find these 5 input values. Okay, so I found these 5 output values, these function values here. Here's your maximum, here's your x-intercept, your minimum, another x-intercept, and a maximum. Let's go ahead and plot these points and then draw a smooth curve through these points. All right, cool. I hope this is the same graph that you have. Please notice that the amplitude, we knew it was going to be 1.5, and it is. From the x-axis up, it's 1.5. We knew that the period was going to be pi. Remember 2 pi over b, right? 2 pi over 2, which simplifies to pi. So from pi over 2 to 3 pi over 2, you can see it completes one period, which is, that period is pi. Yeah, just make sure this is a smooth curve. All right, let's look at another example. All right, we're going to graph this function y is equal to -2 plus 3 times cosine of 2x. Now, let me call a few things out. First of all, notice that there is no phase shift. There's no phase shift. There is, however, a horizontal shrinking happening because of this 2. That's a horizontal shrink. There is also a vertical stretch by a factor of 3. Now, this is the first time there is a vertical translation, and that is -2. That's 2 units downward, 2 units downward. All right, the first thing we're going to do is find the interval, because the interval over which it completes one period. So let me do this. The period is 2 pi over b, remember that. So in this example, it'll be 2 pi over 2, which is pi. Right, everybody? 2 is your b value. Now, I want to say something here. The interval here over which it completes one period is 0 to pi. I do not need to set up the 3-part inequality that we have been doing in the previous examples. I don't have to do that here in this example because there is no phase shift. Because there's no phase shift, I don't have to set up the 3-part inequality to find the interval. The interval is just 0 to pi, okay? All right, what we're going to do is divide this interval into 4 equal parts. This is where we find the midpoint and our quarter points. All right, I'm hoping that you're feeling really comfortable finding your midpoint and your quarter points. I found my midpoint to be pi over 2 and my quarter points to be pi over 4 and 3 pi over 4. It's time to now evaluate our function at each one of these 5 points. All right, I have my table set up. I'm going to start plugging things in. I invite you to pause the video here, plug in each one of these 5 input values, and see if you and I can agree on the 5 output values or the 5 function values. All right, I hope you and I agree on what these function values are. All right, so notice that the highest value is 1. So this is the max. You have a maximum over here as well. The lowest value, the minimum, is -5. And notice that the middle value, function value, is -2. This is the middle valued function value. All right, so let's graph this. All right, at 0, we're at 1 here. So this is a y-intercept. And at pi over 4, we're at -2, so about here. And at pi over 2, we're at -5. 3 pi over 4, we're at -2 again. And at pi, we're back up at the maximum. So then we have this curve happening here, something like that. Now, what I want to show you is that, now my sketch is a little weird, but it'll do. I want to show you that the line going right through the middle is right here, right? The equation for this line is y equal to -2. Y equal to -2. Now, this is the line going right through the middle. Now, please notice that it's y equal to, well, here's the equation right here, right, everybody? Y equal to this constant. Y equal to this constant. This is your middle, sometimes called the middle C, the middle C. It's the line that's going right through the middle of your graph. Now remember, the amplitude describes the height of the graph, both above and below this line that's going right through the middle of the graph. Now, it used to be the x-axis in all the previous examples. It's no longer the x-axis. It's y equal to -2. This is the line going right through the middle. And the height above this line here, let's count 1, 2, 3 units. Also downward, 1, 2, 3 units, right? You can see the amplitude right here. Remember, the coefficient of the function the absolute value of this number will be the amplitude. So you can see here, the only thing that will change the line going right through the middle of your graph from being the x-axis is a vertical translation. All right? All right, let's check out this last example. Well, I have one more for you, but it's not a graphing one. So let's do this one. Notice that this one does have a phase shift. It does have a phase shift. So I'm going to go ahead and set up my three-part inequality in order to find the interval over which it completes one period. There's a phase shift going on. There's a lot going on. There's a vertical stretching of 2 units. This negative is a reflection across the x-axis. The period has also changed because the coefficient of x is not 1. And there's also a vertical translation up 4 units. Man, there's a lot of transformations involved here. All right, let's set up our three-part inequality and solve for x. All right, now that we have that set up, I invite you to pause this lesson and isolate x and find that interval, the interval over which it completes one period. So go ahead and pause this here, and I'll check in with you in just a minute. All right, everybody, I hope you and I agree that the interval is from pi over 3 to pi. This is the interval over which this function completes one period. The interval over which it completes one period. And the period is 2 pi over b, which is 2 pi over 3. We're going to now take this interval here and split it into 4 equal parts, and that is to obtain those 5 key x values. I hope you and I agree on what the midpoint is and what the quarter points are as well. What we're going to do now is evaluate our function at these 5 points, the left endpoint, the right endpoint, the midpoint, and the quarter points, and we will find our maximum, minimum, and our x-intercepts. All right, I have my table set up with my 5 input values, and now I'm ready to evaluate my function at each one of these 5 points. Once again, I invite you to pause this video here and try this on your own and try to get these 5 output values here, and let's check in with each other in just a minute. So go ahead and pause the lesson here. All right, I hope you agree with my function values here. I hope we have the same thing. What I'm going to do now is get this started. Now notice all of your function values are positive. So I'm going to move my x-axis really down low here, way down here. I know my maximum is 6, so I want to show at least up to 6 here, at least. So I'm going to do this, 2, 4, 6. Okay. All right, I try to scale my axes here so that it looks accurate. So at pi over 3, we're at 4. Pi over 2, we drop down to 2. That's your minimum. At 2 pi over 3, we're back up at 4. 5 pi over 6, we jump up to a maximum. And at pi, we jump back down to 4. So please notice that your middle C, if you will, the line that's going right through the middle, is right here, y equal to 4. And so now we can draw the smooth curve here, like that. All right, totally missed that point. Okay, so I hope you can see this, and I hope that you have something very similar. Notice that the height above the middle line here is 2 units, which we would have known from the very beginning just by looking at the equation. 2 units also below, so the amplitude is the absolute value of -2. All right, good job, everybody. Now, before we end this lesson, I wanted to look at this example here. I don't want us to graph it, but I do want us to look at this and see if we can pull some information from it. Get an idea of what the graph would look like. let's start with the amplitude. Now we know the amplitude will be the absolute value of A. And in this case, it's the absolute value of 1/2, which is 1/2. So remember that the amplitude is the coefficient of your function. It's not the absolute value of -1. That represents something else. It's the absolute value of your coefficient of the function, all right? So it's absolute value of 1/2. Now the period, don't forget the period is 2 pi over b. In this example, it is 2 pi over 2. The coefficient of x is 2. So the period here is just pi. Now, the period for the most basic cosine function is 2 pi. So that must mean there is a horizontal shrink happening here for in order the period to be changed like this. There is a horizontal shrink. Now, a vertical translation, that's what the -1 represents. So I am going to say -1. So that is to say, I'm going to add a little more information here. I'm going to say down, it would be a vertical translation down by 1 unit. I'm just going to say down by 1, maybe if I can spell right. Okay, down by 1 unit. Okay, that's what the -1 represents on the front. As far as the phase shift goes, what you're going to want to do is, now this is very important, I hope you pay close attention, 2x minus 3 pi, what you're going to want to do is factor out the 2 so that the leading coefficient is just 1. Now be careful, when you factor out a 2, you're left with x minus 3 pi over 2, right? You can always confirm that you factored this 2 out correctly, because if you distribute the 2 back in, you would get 2x, right, which is the part of the original argument, and this 2 and this 2 would cancel, leaving you with 3 pi, which is what you have here. So we did factor that correctly. Now, the reason why you're going to want to factor the 2 out is because this part here, if I can highlight it, this part here represents the phase shift. And so the most common mistake when identifying phase shift is students say, oh, it's going to be -3 pi or 3 pi units, right? 3 pi units is the phase shift, and that's not correct. It's actually 3 pi over 2 units, right? So be very careful. The phase shift can be identified once the coefficient on x is 1, okay? So you got to factor that out. So in words here, it'll be 3 pi over 2 units. So if I can write that out for us here, just give me a second. All right, so 3 pi over 2, and then you're going to say something along the lines of units, now to the right, all right, to the right. So make sure when you're identifying phase shift, not only how many units, but also in the direction as well. So I like these problems because it has you, without graphing, you get an idea of what the graph will look like before you even graph it using transformations. All right, guys, I hope you really enjoyed this section as much as I have. I'll catch you in a later lesson. See ya.